All right, so accumulation, area under a curve. Like I said, if you can do geometry, this should be pretty easy. So I'm going to give you a function. And I'm going to give you an interval. So that's x from 0 to 4. That's what that means. That's the part you probably don't know what it means. 4 left endpoint rectangles. So, and we would say approximate the area under the curve. Okay, we will have left endpoint rectangles, we'll have right endpoint, we'll have midpoint today. Next Friday, we will move to trapezoids. Okay? Fun is correct. Because this is a function. Oh, I'm so funny. Okay, nobody laughed. How about that? You're laughing at me, not with me? I'm going to scale this so you can see it easier. On the x direction, the y direction I'm going to scale by 2 so I can fit it. And then, so 0, 0. Oh, it helps if I use the right function, huh? It's +1. So 0, 1, 1, 2, 2, 5, 3 is 10, 4 is 17. And so you can see my interval goes from 0 to 4. That's what this is. 0 to 4 on the interval. Okay.
You plug in the numbers, right?
Plug in the numbers?
Yeah. That's what you got to do.
Oh, yeah, plug 0 in
0,
here.
1.
It gives you 1, that's your height, right?
Okay.
1 gives you 2. It's the graph of the quadratic. If you drew this side, it would look like this. Right, your classic parabola. Okay, 4 left endpoint rectangles. That means we need 4 rectangles. So there are 4 gaps here, right, for rectangles? And we're going to draw them so that the left point hits the graph. The left endpoint hits the graph. And I have my 4 left endpoint rectangles. So the left top point of the rectangle is what touches F. Okay. Are you okay with that?
Yeah.
All right. I have no idea. It's been there for a couple days. Okay, so how would I approximate the area under this curve? Calculate the area of all the rectangles and add them up. Is it an under or an overestimate? Okay, so this is going to be an underestimate, right?
Yeah.
So what's the area of the first one? 1 times 1? Because it's 1 high and 1 wide. It's only 1 unit. It's 2 squares, but it's 1 unit. The next one, 1 wide and 2 high. And then 1 by 5. And 1 by 10. And what do we get?
Is he above, and then you have to go from the right, and you could go for
So you guys are, so this is an underestimate. Some of you are automatically thinking, how can I make it more exact? Right? I'm hearing this conversation. That's good. Hunter, what did you say?
I said it would be above it, and you have to have it for the right corners, and then
If you did a right endpoint approximation and then average the two, it would get a good approximation. What did you say, Alex?
I said go from the point where they're touching the curved line. You go from like 4. Yeah.
Create some triangles?
Yeah.
Okay, that is actually the trapezoidal method that I'll teach you next week. And it is a closer estimate. So you guys are on the right track there. The point of calculus is to get an exact answer for that value. And it's called an integral. And I'm not going to really teach you how to do an integral because it involves series and sequences, which you don't know what they are. But it will give you an exact value. Okay, it's basically what we call an antiderivative. So, do you want me to show you a right endpoint? Or do you think you can handle it?
Show us.
Right endpoint approximation.
What is that?
It would be where you put the rectangles on the right endpoint. So basically you'd have these rectangles. That would be a right endpoint approximation. Okay. Do you need me to show you one?
I'm guessing it's the same.
I'm hearing half yes, half no. Okay.
So I like mine better.
Pass those out. Do you want to? I'm going to do the midpoint first, and then I'll do the right approximation. If you want to see the right, you can, but this will be a midpoint. So let's use the same conditions. We're going to do midpoint rectangles this time. Okay, thanks. Everybody got one? They're all front to back, hopefully. Okay, if I want to do midpoint rectangles, what do you think we're going to hit?
Middle.
Yeah, instead of 0 or 1, it's going to be right in the middle at 1/2. So my rectangle is going to be half tall. And this one's going to hit right in the middle. And 3.5. Okay, so you can see I've hit the middle point, right? It's the same thing, you just have different values to work with. So, you guys are still writing, so I'll wait. Okay, for the left, the red rectangle, the width is 1, right? What's the height?
I'm guessing 1.5.
What x value is it? 0.5 or 1/2. Plug it in. What do you get? What's 1/2 squared? 1/4 plus 1. Yeah, so 5/4. What's the width of the second one? 1. And the height? Plug 1.5 in, because that's our x value. It's 2.25 plus 1.
this could be 1.25 if you want a decimal approximation. See how I'm doing it? Okay. What's 2.5? 2.5 squared is 6.25, so 7.25. And then 3.5 squared. I don't think I have that one memorized.
What's squared?
3.5.
12.2.
So 13.25. Four. 25. Check my math there. 25. One, two, 11. It's 25. But notice the difference here in estimates. Okay, you will get widely varying estimates if you use these methods. Do you guys still want me to show you the right endpoint, those of you that asked? Are you good? Tomorrow, just a note, because I'll be gone. Tomorrow you're going to get something that looks like this. Okay. This is an application of integrals. Okay. If I give you a rate function, like the velocity of your car from here to Denver, to find the distance you've traveled, all I have to do is find the area under that curve. Okay. So one of the big things with integrals is if you're given a rate function, here you're given flow rate of an oil spill, and that's what this graph is. If you do an area calculation under the curve, you're going to find how much oil has spilled. Okay, and they use this on oil spills. Because they can calculate the rate it's flowing out because of the amount that's dropping in the oil tanker. Okay, so on this sheet, all you're doing is finding area under curves. It's a practice sheet for applying integrals. Okay? Sound good? The one I gave you is your homework. What I just showed you we'll do tomorrow in class. Any questions?